understand why the same location is freed twice, we need to understand one more thing, that is a copy constructor. So to show that, let me have some other code here. So let's define a new with existing one. So that is the case. So let me use first one. The first one is I have a size of 5 and so on. So here the idea is that we could do, if we have integer variable a, then if integer variable b is already defined, we can declare a new variable with the existing one as initial value. So even if we have a class type, we may use the similar syntax. Then let's see what's happening there. So the intent is that f1 is defined here with a 5 size, and the 5, 6, 7 are pushed to that. So we want to have an identical copy of f1 and then create a new variable f4 like that. So let's compile the program and let's run the debugger there. So we have f4, f1, like that, and then f4 is ready to create. So let's do step over. Then what you see is that f4 p array, f1 p array is the same. So what you get is similar to assignment operator. So we have f1 existing, and the p array is pointing to 5-element array, and then in this instruction we create f4, and then p array is pointing to the same one. So even if we have given the assignment operator overloading, and that assignment operator does not work for this case. So assignment operator works if we declare variables first and then use assignment operator like that. But if we declare new variable with the existing variable as the initial value, the assignment operator overloading does not work. So something else works. So at this moment, what is actually used is copy constructor is called. Copy constructor is called in several cases. The first one is that when you declare a variable with the existing variable as the initial value, we are talking about the variable of a class type, then a special constructor called the copy constructor is called. If we do not provide a copy constructor, the default behavior is a member-wise copy, same as assignment. If we don't provide assignment operator overloaded, member-wise copy happens. Because of that, p array member is shared, so that the same array is shared by two different fstack objects. So what we need to do is we need to provide a special constructor. Constructor means the same name as a class, and then the parameter is a special const, same class type reference. That is a copy constructor requirements. Copy constructor requirements. So we need to provide implementation of a copy constructor. Const, same type, and then parameter name. Here parameter name right is whatever is placed on the right hand side of the initial condition. So here in this case f1 becomes a right part. Then what you need to do is we need to make it the same from right object, but don't share the array, but create a new array for that. So what we need to do is size of the current object being created is same as right, and then TOS is the same as right, and then let's create a new array of size Then using loop through TOS, copy the array. I is right p array I. So this code is similar to assignment operator overloading, but here this one will be called the copy constructor. When you create a new object, this is called. So this will be called a very special case. First, when you declare a variable with the initial value of existing one, then instead of a regular constructor, at this moment the copy constructor will be called. So we can give a message here. Let me copy this one. Say that here copy construct is called. Okay. So when you provide the copy constructor, then the sharing of array is now taken care. So let's run the debugger. P1, F1, P array is there. So if I do step over, now the address of P array in F4 and F1 are different because we have defined this way. So that is taken care. Once you give the copy constructor, that is taken care for this part as well. So when copy constructor is called is let me move the copy constructor part here, just logically. There, copy construct is called the first, like this example, second, and the third copy constructor is called. When you pass an object to the function call, when you pass a value to the function parameter, we know that this argument is copied into function parameter. At that moment, the copy construct is utilized instead of a regular assignment. And also when you return a value, so in this case, this one is a function return value is assigned into F3, then the return value, when you receive the return value, so here we have a return value which is the object, then copy construct is used to receive the value. So once you give a copy constructor this way, the previous problem cascading the assignment which has some memory free violation is there, that is taken care of. Now copy constructor takes care of that. Compile the program, now run it, there's no more error occurs there. So that's the importance of a copy constructor. So in summary, when you have a class definition which has a pointer, then regular constructor, a regular assignment may end up sharing the dynamically created memory. So you need to provide overloading of assignment so that assignment something like this does not end up sharing the dynamically created memory. Also, the copy constructor needs to be provided so that some like this usage, or when you pass the object, or when you receive the object from function call, no sharing of a dynamic memory is there. So you need to provide a copy constructor and the assignment operator overloading to avoid any sharing of a dynamic memory.